Welcome to Quiet Night Chronicles, where we explore the gentle mysteries of our past. Tonight, we drift back to the calm waters of medieval Scandinavia, where master craftsmen created what many consider the finest ships of their age. The Norse longship was more than a vessel. It was a masterpiece of engineering that whispered across oceans and rivers alike, carrying its crew with grace and purpose through waters both familiar and unknown. Imagine yourself standing on a quiet Norwegian shore over 1,000 years ago. The morning mist rises from the fjord's still surface, and there, resting peacefully against the wooden pier, lies a longship. Its elegant curves seem to flow like water itself, each line purposeful yet beautiful. These ships represented something remarkable, a perfect marriage of function and artistry that would not be matched for centuries to come. The story of longship construction begins with a technique so innovative, so perfectly suited to its purpose, that it revolutionized shipbuilding across Northern Europe. This method, known as clinker construction, was deceptively simple yet profoundly sophisticated. Picture the gentle rhythm of shipwrights' tools as they shaped each oak plank with meticulous care. In clinker construction, overlapping planks were carefully fitted together, like scales on a fish, each one positioned with mathematical precision. The shipbuilders would begin with a single keel, the backbone of the vessel, carved from a mighty oak tree. This keel was selected with extraordinary care, often from trees that had grown slowly in harsh northern climates, their wood dense and resilient from years of patient growth. From this foundation, the craftsman would attach the first strakes, the long planks that formed the hull's sides. Each plank overlapped the one below it by precisely the right amount, creating a series of gentle steps that rose from the waterline to the gunwales. The overlapping edges were sealed with tarred rope or animal hair, creating a watertight bond that could flex and move with the sea's rhythm. What made this construction truly revolutionary was its use of iron rivets. These weren't crude fastenings, but carefully crafted connectors that held each plank to its neighbor, while allowing the entire hull to remain flexible. Imagine the soft sounds of hammering as smiths shaped hundreds of these rivets, each one custom-fitted to its specific location on the hull. The genius of this flexible construction becomes clear when you picture a longship riding ocean swells. Rather than fighting the waves with rigid resistance, the hull would gently bend and twist, moving with the water's natural motion. This flexibility prevented the catastrophic cracking that plagued more rigid vessels, allowing longships to survive storms that would destroy other craft. The wood itself was chosen with extraordinary wisdom. Oak was preferred not just for its strength, but for its particular grain patterns and natural oils. Shipbuilders would walk through forests, selecting trees that had grown with the perfect curves already formed by nature. A tree that had bent towards sunlight might provide the ideal timber for a ship's curved prow, while another, with a long, straight trunk, would become the keel. Perhaps the most remarkable feature of Norse longships was their incredibly shallow draft, typically just 3 feet from surface to keel. This measurement might seem insignificant, but it opened up an entire world of possibilities that no other vessels of the time could access. Picture a longship gliding silently up a river, its crew able to reach destinations that seemed impossible to other mariners. This shallow design meant that longships could navigate virtually any body of water deeper than 3 feet. They could cross vast oceans, then turn seamlessly into river mouths, continuing inland for hundreds of miles. Imagine the strategic advantage this provided. While other ships were confined to deep harbors and coastal waters, longships could appear anywhere there was sufficient water to float. The shallow draft also made beaching incredibly simple. When approaching a foreign shore, the crew didn't need to search for a proper harbor. Any gently sloping beach would suffice. The ship could be run right up onto the sand, allowing the crew to disembark directly onto dry land. For loading and unloading cargo, or for quick departures, this capability was invaluable. This design feature also provided safety advantages. In shallow coastal waters, filled with hidden rocks and reefs that could destroy deep-drafted vessels, longships moved with confidence. Their minimal draft meant they could pass over obstacles that would trap or damage other ships, giving them access to protected bays and hidden anchorages. The construction process for achieving this shallow draft required extraordinary skill. The hull had to be shaped to displace just enough water to carry its load while maintaining stability and seaworthiness. Too shallow, and the ship would be unstable in rough seas. Too deep, and it would lose its primary advantage. The master shipwrights achieved this balance through generations of accumulated knowledge and intuitive understanding of how wood and water interacted. The selection and preparation of oak planking represented one of the most sophisticated aspects of longship construction. Each plank was not simply cut from available timber, but carefully chosen and shaped to fulfill a specific role in the vessel's structure. The process began in the forest, where experienced shipbuilders would identify trees with the ideal characteristics for shipbuilding. These craftsmen used specialized tools, particularly the adze, a curved blade mounted perpendicular to its handle. With this tool, they could shave and shape wood with remarkable precision, following the natural grain to create planks that were both strong and flexible. The sound of the adze working would have been a familiar rhythm in shipyards, a steady scraping that gradually revealed the perfect curve, hidden within raw timber. The oak planks were shaped not just for their final position on the hull, but also to take advantage of the wood's natural properties. Shipbuilders understood that oak's strength lay not just in its density, but in the way its grain ran. They would orient each plank to place the strongest grain direction where the greatest stress would occur, creating a hull that was remarkably resilient to the forces of wind and wave. Before installation, planks were often seasoned, allowed to dry slowly under controlled conditions. This process removed excess moisture that could cause warping or cracking later. Some planks were even steamed and bent while green, allowing shipbuilders to create curves that would have been impossible to achieve with dry timber. The result was a hull where every piece fit together with almost organic harmony. The steering system of Norse longships represented another triumph of practical engineering. Instead of the stern-mounted rudders that would later become standard, longships used a side-mounted steering oar called a stiri. This elegant solution to the problem of ship control was both simple and remarkably effective, giving these vessels a level of maneuverability that amazed contemporary observers. The stiri was positioned on the right side of the ship, which came to be known as the starboard side, literally meaning steerboard. This placement wasn't arbitrary, but represented careful consideration of how ships moved through water. The steering oar was attached through a system of leather loops and wooden blocks that allowed it to be adjusted for depth and angle while remaining securely connected to the hull. This steering system provided several advantages over other contemporary methods. The helmsman could make subtle adjustments to the ship's course with gentle movements of the steering oar. In tight spaces, navigating narrow rivers or maneuvering near obstacles, the longship could be turned with surprising agility. The side-mounted position also protected the steering mechanism from damage during beaching, as the oar could be raised clear of the seabed. The craftsmanship required to create an effective styree was considerable. The steering oar had to be shaped to provide just the right amount of resistance to the water flow, while remaining light enough for one person to control. The attachment system had to be strong enough to handle the forces of steering, while flexible enough to allow the necessary range of motion. One of the most ingenious aspects of longship design was their sophisticated combination of sail and oar power. These vessels weren't simply sailing ships that could be rowed in emergencies, or rowing vessels with auxiliary sails. Instead, they were designed from the beginning to excel under both forms of propulsion, switching seamlessly between them as conditions demanded. The sailing rig was elegantly simple, a single square sail that could be raised or lowered quickly as needed. This sail was typically made from wool cloth, woven tightly enough to catch wind effectively, while remaining light enough for easy handling. The wool was often reinforced with leather strips at stress points, and the entire sail could be treated with various substances to improve its water resistance. What made this system particularly brilliant was how quickly the transition between sailing and rowing could be accomplished. When wind conditions were favorable, the crew could raise the sail and make excellent speed across open water. When the wind died or became unfavorable, or when entering waters too confined for sailing, the sail could be lowered and stowed, and the crew could seamlessly transition to rowing. The rowing system itself was highly refined. Each ship carried multiple sets of oars of different lengths, allowing the crew to adapt to various conditions. The oar ports, openings in the hull through which the oars extended, could be sealed when not in use, maintaining the ship's watertight integrity. The rowing benches were positioned to give each oarsman optimal leverage while maintaining the ship's balance and trim. As we explore the diversity of Norse shipbuilding, we discover fascinating regional variations that developed across Scandinavia. While the basic principles of longship construction remained consistent, different areas developed their own refinements and specializations, each adapted to local conditions and needs. These variations tell a quiet story of innovation and adaptation that unfolded over centuries. In the Norwegian fjords, where ships needed to navigate narrow, deep waterways, builders developed techniques that emphasized maneuverability and stability in confined spaces. The steep-sided fjords created unique wind patterns, and local shipbuilders adapted their sail plans and hull shapes accordingly. These ships often featured slightly deeper drafts than their counterparts built for river navigation, trading some shallow water capability for improved performance in the fjord's challenging conditions. Danish shipbuilders, working in waters that included both open seas and extensive river systems, developed their own approaches to the challenge of versatility. Their ships often featured subtle modifications to the hull shape that improved performance in the shallow, muddy waters of river deltas, while maintaining the seaworthiness needed for coastal voyaging. Swedish longships, built for navigation of the Baltic Sea and its many islands, incorporated features that reflected the unique conditions of that relatively enclosed body of water. The Baltic's lower salinity and different weather patterns influenced design choices, and Swedish builders developed techniques for dealing with ice conditions that their southern neighbors rarely encountered. These regional variations weren't just technical differences. They represented the accumulated wisdom of generations of shipbuilders, each group solving the specific challenges presented by their local environment, while maintaining the fundamental excellence that made longships so remarkable. The archaeological record provides us with remarkable windows into longship construction through the preservation of actual vessels in ship burials. These discoveries allow us to examine the craftsmanship of Norse shipbuilders with our own eyes, seeing techniques and details that no written description could fully capture. Each preserved ship tells its own quiet story of skilled hands and thoughtful engineering. The most famous of these archaeological treasures is the Gokstad ship, discovered in Norway and dating from around 890 CE. This magnificent vessel, stretching 78 feet in length with a beam of 17 feet, demonstrates the sophistication that Norse shipbuilding had achieved by the late 9th century. The ship's capacity for 32 rowers speaks to its substantial size, while maintaining the elegant proportions that made longships so effective. Examination of the Gokstad ship reveals construction details that written sources never recorded. We can see exactly how the planks were shaped and fitted, how the rivets were positioned and formed, and how the various structural elements worked together to create the finished vessel. The preservation is so complete that archaeologists can study tool marks left by the original builders, giving us intimate insight into their working methods. Other ship burials have provided additional pieces of the puzzle. Each vessel shows both adherence to established techniques and individual variations that suggest continuous refinement and experimentation. Some show evidence of repairs and modifications made during their working lives, telling stories of long service and careful maintenance. These archaeological discoveries also preserve organic materials, rope, textiles, and leather, that rarely survive in other contexts. We can examine the actual materials used for rigging, see how sails were constructed and reinforced, and understand details of the ship's equipment that would otherwise be lost to time. The evolution of longship design didn't happen overnight, but developed gradually from earlier Scandinavian boat-building traditions. This progression tells a gentle story of innovation building upon tradition, with each generation of shipbuilders adding their own refinements to inherited knowledge. The earliest ancestors of the great longships were much smaller vessels, designed primarily for fishing and local transport in the protected waters of Norwegian fjords. These early boats already showed some characteristics that would become hallmarks of later longships: clinker construction, shallow drafts, and emphasis on flexibility over rigid strength. As Scandinavian communities grew more prosperous and their maritime activities expanded, the demand grew for larger, more capable vessels that could handle longer journeys and carry greater loads. The transition from local fishing boats to ocean-going longships involved solving numerous technical challenges. Scaling up required new approaches to structural strength. Techniques that worked for 20-foot boats needed significant modification to create seaworthy vessels 3 or 4 times that length. Shipbuilders had to develop new methods for ensuring that larger hulls remained watertight and flexible. The addition of sailing capability represented another major evolutionary step. Early boats were primarily powered by oars, but as voyages became longer and more ambitious, the efficiency of sail power became increasingly attractive. Integrating sailing rigs into existing hull designs required careful engineering to maintain the ship's other desirable characteristics, while adding this new capability. This evolutionary process continued throughout the longship era, with builders constantly refining and improving their techniques. Each new ship incorporated lessons learned from previous vessels, gradually pushing the boundaries of what was possible with available materials and tools. As we draw near the end of our gentle journey through the world of Norse longships, we can begin to appreciate why these vessels represented such a remarkable achievement in marine engineering. They solved fundamental challenges that had limited maritime activity for centuries, creating ships that were simultaneously seaworthy and versatile, fast and maneuverable, elegant and practical. The longship's greatest achievement was perhaps its versatility, the ability to excel in multiple roles that other vessels could only handle individually. A longship could cross the North Atlantic, navigate up rivers to inland settlements, serve as a coastal trader, or function as a naval vessel. This flexibility gave Norse communities unprecedented mobility and access to resources, trade opportunities, and new territories. The construction techniques developed for longships also influenced shipbuilding far beyond Scandinavia. The clinker construction method spread throughout Northern Europe, and variations of longship design appeared in many different maritime cultures. The emphasis on flexibility over rigidity became a lasting principle in wooden shipbuilding, influencing vessel design for centuries to come. Perhaps most remarkably, longships achieved their excellence using only hand tools and traditional materials. No complex machinery or exotic substances were required. Just skilled craftsmanship, carefully selected timber, iron for fastenings, and the accumulated wisdom of generations of shipbuilders. This represents engineering at its most elegant. Sophisticated solutions achieved through deep understanding rather than complex technology. The legacy of Norse longships extends far beyond their immediate practical achievements. They represent a way of approaching engineering challenges that emphasized harmony between human needs and natural materials, between innovative design and traditional craftsmanship. In our modern age of complex technology, there's something deeply satisfying about contemplating these vessels that achieved such excellence through thoughtful simplicity. As we reflect on these remarkable ships and the skilled hands that created them, we're reminded that the greatest engineering achievements often come not from adding complexity, but from understanding fundamental principles so deeply that elegant solutions emerge naturally. The Norse longship stands as a testament to what human ingenuity can accomplish when knowledge, skill, and creativity work together in harmony. If you found this journey through the world of Norse longships peaceful and enlightening, consider subscribing to Quiet Night Chronicles for more restful explorations of history's gentle mysteries. Until next time, sleep well, and may your dreams carry you across calm waters to distant